welcome back to this tutorial. We are almost done with chapter 2 for data preprocessing. I cannot wait to start making the machine learning models. We just need 2 more tutorials to make our dataset perfectly prepared before starting the models, and then we'll be good to go. Okay, so today we are going to talk about the fact that we need to split the dataset into a training set and a test set, and I'll explain why we need to do that right now. So let's go to our dataset. So we have our 10 observations, and this is the dataset. This is the whole dataset. And what we should do in any machine learning models is what we are going to split this dataset into 2 separate sets, which are going to be the training set and the test set. Now, why do we need to do this? Well, when you take a step back and focus on the machine learning itself, you understand that this is about a machine that is going to learn something. Well, here it's your algorithm mature model that is going to learn from your data to make predictions or other machine learning goals. And so machine learning model is going to learn to do something on your dataset by understanding some correlations that there is in your dataset. And imagine your machine learning model is learning too much on the dataset, like it's learning too much to correlations. Then I'm not sure its performance will be great on a new set with slightly different correlations. You know, it's like a student who is learning by heart his lesson, and then when he takes the exam, he might be in trouble because he learned too much his lesson by heart, and he doesn't manage to make the connection between what he learned and the exam. And it's the same for machine learning. We are going to build our machine learning models on a dataset, but then we have to test it on a new set which is going to be slightly different from the dataset on which we build the machine learning model. So we have to make 2 different sets of training sets on which we build the machine learning model and a test set on which we test the performance of the machine learning model. And the performance on the test set shouldn't be that different from the performance on the training set, because this would mean that the machine learning models understood well the correlations and didn't learn them by heart, so that he can adapt to new sets and new situations. Okay, so that's the idea about splitting the dataset into a training set and a test set. So we are going to learn how to do it right now in Python. So now open the Spider. Okay, and I have my section ready for splitting dataset. Okay, so you're going to see that it's very simple. It's going to take us 2 lines. And as usual, let's start by importing the library that is going to do the job for us because we want to be efficient. The world is going so fast, so we want to solve our business problem in the most efficient way. Okay, so the library we are going to import is a new library we haven't met yet. It's the model selection library, still from scikit-learn. Okay, so let's import the library by typing from sklearn.model selection import train test split. Remember when I told you that the library's names are quite intuitive? Well, that's the case trying to split. It couldn't be more clear. Okay, so we imported the library. We're fine with that. And now let's build our training and test sets. So what we are going to do is we are going to create xtrain, then xtest, ytrain, and ytest. Okay, so xtrain is the training part of the matrix of features x, and xtest is the test part of the matrix of features. Ytrain is the training part of the dependent variables that is associated to xtrain here. That means that we have the same indexes for both with the same observations. And ytest is the test part of the dependent variable vector associated to xtest. And then we are going to add equal, because we are going to define these variables at the same time. So equal with train test split parentheses. And then we're going to put our arguments. So let's inspect it. Let's press Ctrl+I. Okay, so the first parameter is arrays. And then what is arrays? That's simply the matrix X, that is the matrix X features of independent variables of our dataset, and then Y, which is the dependent variables. So we want to type X, Y here, and that's what they mean by arrays here. Okay, then the next parameter is test size. So we are going to add here, test underscore size equal. Okay, so very simply, that's the size of the test set you want to choose. So for example, if I put test size equals 0.5, that is 50%, like this. That means that there is going to be half of your data going to the test set and half of your data are going to the training set. But usually, whenever choose 50% for the test size, would choose smaller percentage. A good choice of the test size is generally 0.2, like 20%. That's a good choice, or 0.25 or 25%, or even sometimes 0.3. And in some rare cases, you will find 0.4. But really, I have never seen 0.5. So here we are going to choose 0.2. So that means that since we have 10 observations, it's good to let's go back to Variable Explorer and find out what we have 10 observation. Okay, that means that once we do the train test split, we were going to have 2 observations in the test set and 8 observations in the training set. Okay, and that's all what we have to input. Well, let's go back to the object inspector to see the next parameter. Okay, so here we need to input the train size, but since test size plus train size equals to 1, we don't need to put inside, that will be redundant. But then we are going to use the parameter of random state. And that's just for the purpose for this course, because I don't want you to worry about having different result than mine. So you're going to have the same logical result, but you might have different results if we don't put a random state parameter. So we're going to use this random state and set it to the same number so that we have all the same results. So let's add here, random state equal. Then we can choose whether we want. Good choice number is 42, and a regular number I choose is 0, so I change slightly here as 0. You can put a random state 0 in your code if you want to have exactly the same result as mine. It's really as you want. Okay, so we are done actually. That's the 2 lines that we have to write to split correctly the data set into the training set and test set. So let's see what happens. Let's execute these 2 lines. Here we are. It's executed properly. So now, of course, let's take a look what happened. Let's go to the Variable Explorer here. Here we have some new variables. Remember, before we had the dataset, the X matrix of features, and the Y dependent variable vector. And now we also have the X train, X test, Y train, and Y test. So let's take a look at them one by one. Okay, X trains. Since we choose a test size of 20% or 0.2, we would normally have 8 observations, the train set, and 2 observations in a test set. So let's make sure that's the case. Okay, so we have our 8 observations in the train set. Now let's get a test set, the observation in the test set. Okay, 2 observations in test set. Perfect. And now let's check that it's the same for Y train and Y test. Great. 8 observations and 2 observations in Y test. So now let's open X train, X test, Y train, and Y test to compare. Okay, so to summarize what the train split is about here, the above we have the training set with the X train matrix of independent variables and Y train of dependent variable vector. And below we have the test set with the matrix of independent variables of X test and the dependent variable vector of Y test. And so what happened is that we are building our machine learning model on this training set by establishing some correlations between the independent variables here and the dependent variable here. And then once the machine learning model understands the correlation between the independent variables and dependent variable, we will test if the machine or the model can apply the correlations you understood based on the training set on the test set. That means that we will see if we can predict that this customer number 0 here is not going to buy the product, and if this customer number 1 here is not going to buy the products either. And he's going to be able to predict that based on what he learned on the training set. So the better he learns the correlations in the training set, the better he will be predicting the result in the test. But if you learn too much by heart, the correlations of the training set, by learning them by heart and not understanding them, then he will have trouble predicting what's happening on the test set. Because since he learns by heart correlation, he didn't understand quite well the logic and he wasn't able to make a good prediction. Then we call it as overfitting, and we will be talking about that in further details in regression section. And we will learn how to use regularization techniques to prevent this. But for now, it's really important that you understand that we need to make two different datasets: the training sets on which the machine learning model learns, and the test set on which we test if the machine learning model learned correctly the correlations. Okay, so we are done with a train task split in Python. So that's it for this tutorial. You now know how to split your dataset into training set and test set. This is a must-do in any machine learning models. You have to test the performance of your machine learning model into separate test set. So congratulations! Now you are almost ready to begin the journey of making an exciting machine learning models. We just have one thing to do left, such as feature scaling. You will understand in the next tutorial why it's so important to do this. So I look forward to seeing you there. Enjoy machine learning and have a good day. See you.